You have to figure out whatever makes you happy at whatever job you do. It's just, if I could teach you anything, it's that. Okay, so 0, -9 pi over 9, -18 pi over 9. So -5, if you want to think about this down here being -4.5, -5 would be like right here. Just a little closer to the 9 than the 0. And to find the reference angle, we have to find the difference between these two, which is 4 pi over 9. Can you guys tell that there's 4 pi over 9 in between those two? Yes, we can tell, Mrs. Talbot? Great. Okay. Now I'm going to extend my lines out. And then I'm going to relabel in the positive direction. So this is 0. This is positive 9 pi over 9. And this is positive 18 pi over 9. Okay, so up here, this would be 4 pi away from 0. And here, this would be 4 pi away from 9. Does that make sense? So this is 4. So this is 4. So this is 4. What's 9 plus 4? 13? And 18 minus 4 is 14. Okay, so quadrant 1 is 4 pi over 9. Quadrant 2, 5 pi over 9. Quadrant 3, 13 pi over 9. Quadrant 4, 14 pi over 9. Positive coterminal. So we have -5 pi over 9. What one of my 300,000 labels up here is 360 degrees? 18 pi over 9. So that makes 13 pi over 9, which is not really shocking because I already labeled that 13 pi over 9. And -5 minus 18 is -23 pi over 9. Now if you could find number 12, please. Number 12. Numero 12. Fluent. Mm. We'll come back to 7 through 10 next week. We'll do them. Don't worry. I just wanted to be consistent because I'm a Virgo. Okay. So A equals B equals P equals H equals K equals. Okay. A in this case is 1/2. I have to tell you, I don't love it when A is 1/2. It makes the graph hard to draw. I don't like it. Just my whining for the day. B is 4. period is 2 pi. What? Yeah. Excellent question. B is always in front. It's the multiplier. Always feel free to add this on if that helps you. I always do that. That helps you. Okay. 2 pi over 4 reduces to pi over 2, which I notice before I start my problem is 2 boxes. So this is going to be extremely irritating because the wave is going to be not only tiny up and down, but tiny left and right. H is 0, K is 0. Okay, midline. Oh no, I already messed it up. It's fine. I'm not going to graph the midline because it's the axis. Um, this is the part I was whining about earlier. The amplitude is 1/2, so yeah. This one's miniature. I also really love it when I have to write my line right through the labels of the x-axis. It just really makes my day. No. Mm. Mrs. Abbott, why didn't you go in and change the scale on the y-axis? I don't know. I don't know. It's totally possible. I could have done it too. I don't know why I didn't. Next year. Okay, anyway, cosine. So locator point is h comma k plus a. H comma k plus a. So 0, 1/2 is right there, which makes sense to me because this is a positive cosine, so I should start on the top line. Period is 2 boxes, so I'm going to go 2 boxes away to make my end point. And then general shape of positive cosine is this. And I have to fit this whole wave in between these two little dots here. So I'm going to move the middle dot first, and then the first and third dot. Tiny baby wave. Okay, now can you guys please flip to the quiz 2 review? Quiz 2 review. Okay, first thing I want to tell you, are you all listening? I know you're exhausted, I could tell. I'm not stamping on Monday. Okay, that doesn't mean that you ignore the quiz 2 review. I'm just saying that I'm not stamping on Monday for a reason, but I do want to go over the directions of this. Rewrite each series using sigma notation in terms of both T0 and T1. Do you know what that is? The E thing, right? Okay. If you need help, of course, I've got it back here. Here's your term 0. Here's your term 1. You're not supposed to do anything else. Just rewrite them in sigma notation. Okay. Now these guys down here, evaluate each arithmetic series described. This, when you see those words, that means find the sum. Evaluate a series means that there's pluses in it, so find the answer. And these are all going to use the sum equals n over 2 first term plus last term Gauss formula. I feel like you could probably do problems 1 through 8 without any problem. I mean, you might have to think, but you have everything you need as far as what I've taught you to do 1 through 8. Evaluate each geometric series described. We have not made a formula for geometric yet. We're doing that today, just so you know. And then look at the back. These three were the ones I was warning you about off of that spicy one, which was number 53C. And I'm telling you this because there are people in this room who don't need to be called out, who like to figure stuff out on their own. And you have the ability to do these if you start by looking at problem 53C, that spicy one I was talking about the other day. And I know there are people who will go home and will have fun trying to figure these out, so I wanted to point you in that general direction. But I am not stamping, and we are actually going to go over this on Monday. It's not today, but it is Monday. So, just so you know. Okay, back to the stamp sheet side. Real quick, so today's goal is to finish 81 through 87. And then the homework is the quiz 2 review, as I have said. I'm not stamping it on Monday. And notice the quiz is not till Friday. So you have time. Okay, no stress, just deep breath. It's all okay. All right. We are not working in the packet anymore. You can just put that aside. And then pick up where we left off with Mr. Hanks. We only got to 82. I'm going to tell you something that's going to make you happy. 83 to 85, I've combined into one problem because I'm the nicest lady. Okay, now in there is something called derivation of a formula. Derivation is what you do in calculus all the time. But for us, what it means is we actually go back and figure out what a formula is saying. We did it with the Gauss problem where I did the 100 and the 1 to 100, and then I flipped it around and did the 100 to 1, and we sort of figured out where the pieces went in Gauss's formula. That was a derivation. The geometric one, I'm going to be honest, in the middle of problems 83 through 85, I'm going to lose some of you. And that's okay, because at the end of it, we're going to put a box around the formula. So for those of you that I lose in the middle of the derivation, you'll get the formula in the end with a beautiful box around it. Other people will enjoy the derivation. So anyway, okay, so just to remind you back to Mr. Hanks, he was standing in line to buy a lottery ticket, picturing his adorableness here. And he had two options. It was payments over time, if you remember, and or a lump sum of 51%. I believe, and we talked about the payments over time. So this would be his first payment. That would be his first payment, $1,500,000. And our conclusion there was that he could buy a lot of shrimp with that. I remember, because I think that that would be the thing he would want to buy. Yeah. Anyway, and then I reminded you from math 1 how to get a multiplier from a percent increase. So you take 100% plus 5% because it's increasing, move the decimal over 2 spots, and that gives you a multiplier. Again, I also really like to write the geometric one in terms of the first term because I'm too lazy to go back and find them here. The last thing we did was we plugged in 20 to find out how much his 20th payment would be. And he's very excited about the amount of shrimp that he could buy with $3,790,425.21. Okay. Now back to Mr. Hanks. I don't even remember what C is. Oh, while I'm here, here's the agenda. We're doing 82C to 87.
You got tissues?
I do. Okay. And the homework is the quiz 2 review worksheet, which I have said I'm not stamping on Monday. And here's my joke. Okay. What? Okay. At least one person liked it. I'm excited. Okay. C. When you add up the terms of the sequence, to determine the total over 20 years, you're calculating the sum of the geometric series. Show the geometric series. Okay, so we know that he is going to have 1,500,000 for the first payout. That's first year. And then I need a calculator because I'm special. The multiplier we decided was 1.05. So I multiplied 1,575,000 for the second year's payout. Still a lot of shrimp. Times 1.05. 1,653,750 plus ... Now I'm getting too lazy. But do I know the last number? Yes, I calculated it up here. 3,790,425.29. Okay, and when we're too lazy to write the series out, we write it in summation notation. I have to be careful saying sigma. Apparently, in some of my classes, they can't handle it. Yeah. No.
Oh, really?
Oh, absolutely not. Yeah, fourth period. Juniors. Boy, juniors, they can't handle it. Oh my goodness. Okay. I just told them that the Greek alphabet has been mine since the 1500s and it remains mine. It's at least. Okay. So you draw sigma. You put the equation next to it. So I got the equation from up here. We did this the other day. And then we're starting at term 1. And what term was this? $20, because we plugged in the 20 to get that number. So if you want to, grab whatever you've been using for a pink pen. Okay. What's wrong, honey? I don't really draw sigmas great. Thanks, though. That's actually a false statement.
But like
For most of them. For us starting out, it's always. I think on the team test we have some spicy ones where it's not one. Okay, now for D, we're gonna actually skip it. D is asking us to brainstorm how we could add up all these numbers. But I think we could do that after we figure out what the formula is. So we're gonna pause on that, come back to it. Okay, now this, before you criticize me, this is a capital S that I had to white out. So please make that an S, not a 5. Let me just head your criticism off at the pass. Okay, so our goal is to add up the numbers for Mr. Hanks. But what we're going to do first is we're going to figure out the formula using much easier numbers because I don't know if you noticed, but Mr. Hanks' numbers were kind of spicy. and I don't really want to figure out a formula using Mr. Hank's numbers. Okay. So I picked just a random series, 2, 10. Can you tell what it's multiplying by? 5. Okay. So what I'm going to do is I'm going to take the series and I'm going to multiply it by 5. So again, you'll see why in a second. Let me actually read you this notation, by the way. This says the sum of 6 numbers right here. So you say the sum of 6 numbers, 2 plus 10 plus 50 plus 250 plus 1250 plus 6250. So this is saying 5 times the sum of 6 numbers. Okay, and what I'm going to do is I'm going to take each term and multiply them by 5. So like I'm basically multiplying both sides by 5.
Those are both S's or?
No, this is a 5. This is an S. And the reason I'm multiplying by 5 is because the multiplier in this particular series is 5. You just write the word sum, maybe. So right now, all I'm doing is multiplying the whole series by 5. And you'll see why. You're like, why are you doing that? You'll see why in a second. So I'm just taking these numbers up here. I'm multiplying them by 5. What I want you to see is that I shifted the whole series up one spot. Can you guys tell? I took this whole series and shifted it up one term. That's what happens when you multiply by the multiplier. And now what I'm going to do is subtract the original series from it. Now, luckily, you don't need to discover this. Somebody already did a long time ago. I don't know if it was Gauss. I don't know who it was. But luckily, we don't have to discover it. We just have to use their amazing discovery. Okay, and so if I subtract these, does it make sense to you that the 10s would cancel and the 50s would cancel and the 250s would cancel and the 1250s would cancel and the 6250s would cancel? And that was the whole point of multiplying it by 5 and then subtracting 1. Okay, because it gets me down to fewer numbers. Now, what would this side be? What's 5 times the sum of 6 numbers minus the sum of 6 numbers? Okay, what's 5x minus x? 5x minus 1x. 4x. Okay, so what is left? And I want to start with this guy because it's subtraction. So 31,250 minus 2. So the sum of this is 7,812. Mrs. Talbot, Mrs. Talbot, Mrs. Talbot. Why did you not just type 2 plus 10 plus 50 plus 250 plus 1250 plus 6250 in a calculator and get 7,812? Why did I go this whole rigmarole? Well, what I want to do now is apply it to an abstract situation with letters in it so that I can take this and figure out the formula that works for all of them. That's what derivation is. Okay, so we're going to say the general series that we have here, so this is the sum of n numbers, is 2 plus 10 plus 50 plus 250 plus 1250 plus dot 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 plus 2 times 5 to the n minus 1. Okay, does this ring a bell at all? From that spicy one we did the other day where I said, this is preparing you to do something else. You remember that?
No.
It was C on number 53, and I said the number's not gonna come out nice.
Oh.
And I said that this was the first term, second term, third term, fourth term, fifth term, and term, because that's what you would get when you plugged in n into that field. Okay, so all I did was I listed a bunch of the terms, I put plus dot 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 and then the equation. So the equation of that thing is 2 times 5 to the n minus 1. Okay, what I'm trying to do is take my techniques that I did earlier and now use the general equation to figure out an actual formula that works for all of that. Okay, so I'm going to take this thing and I'm going to repeat this process here. So I'm going to do 5 times it first. Okay, and this is the hardest moment of the entire day. What would this be if I multiplied it by 5? And what we can do to make it easier on ourselves is we'll just go like this. There are people in here who will understand what happened there later, but for most of us, it's just easier to multiply it by 5 for the moment. Okay, now I'm going to subtract off the original and see what cancels. Okay, now you have to have a little bit of imagination and remember what we did before. Okay, what was this side? So looking up here, we're right here in this step. What was this side? 4, right? Okay, now what canceled? Okay, let me ask you it this way. What were the 2 things that were left after the canceling? Okay, so 2 and 31,250 were left, right? Okay, so the only things that are going to be left in this situation, this is where you have to have a little bit of imagination. You have to imagine the 6250s here. You have to imagine that right in front of this is going to be a 2 times 5 to the n minus 1. And the only 2 things that are left over is the bottom left and the top right. Just like here, the only things left were the bottom left and the top right. There's where your little bit of imagination is required. Okay, so then it's subtraction. So I'm going to do this first. Okay, now this is the hardest moment of the derivation right here. And this is where I'm going to lose a lot of you, and that's okay. No. Okay. I have all the faith that someone in this class will be able to tell me. How do I change the equation by multiplying it by 5? How do I change the equation Why multiplying it by 5? Think about it.
Because you're gonna apply that, yeah, 10 times. Yeah, you might as well just sell it at this point.
Nope.
You just take off the -1.
Yeah, you just take off the -1 on the exponent because what I said before is multiplying by 5 shifts the whole thing down a spot.
In -1.
Okay, so what we're saying is this and the -1 cancel. So this becomes 2 times 5 to the n minus 2. And then divide by 4. Jacob. Okay, so the only thing we have left to do then is take these numbers and replace them with the symbols that they were in the original problem. So if I lost you, this is where you come back. Nope. You, no. Are you serious right now? That's so cool. Oh, yeah. That's awesome. Okay. Now, sometimes you're going to write this as S sub n. Sometimes you're going to write this as sum. We already talked about who likes this and who likes this. It's fine. These two things are the same thing. Okay, now here are my questions. In the very original problem here, I'm pointing here. What was the 2? The start. Okay, so first term times. What was the 5? Multiplier to the n minus. What was the 2? The start again. And then where did the 4 come from? Over here. Multiplier minus 1. Now you have the formula to do the sum of any geometric. But not only did I just give you the formula, we actually derived it so you can see where all the numbers came from. Jack's like, I wish I had more than 30 minutes of sleep last night.
I was here and understood everything.
It's okay.
I'll figure it out.
You will, I have no doubt. Okay, so write down number 86, and we're just going to use the formula. So this is more of a normal problem. We're going to plug in all of those things, use our calculator to calculate the sum. And then number 87, we go back and figure out the amount that Mr. Hanks can get. Mr. Hanks is waiting patiently for us to do so. He would like to know. Which one is it? Which one of the options would be better for his shrimp purchasing? Okay, so what we're going to do, so notice that the sum formula for a geometric requires 3 things. It requires the first term, the multiplier, and the number of terms. And what is the first term in this series?
1.2.
What's the other number in the problem? 30. Okay, now how can you tell that 30 is term 1 and not term 0? Yes, nice. It's got the n minus 1 on the exponent. Okay, the multiplier in this case is 1.2, and it says the first 30 terms. I hate it when there's two of the same number in a problem, but it's fine. I will live. Sum equals first term times multiplier to the n minus first term over multiplier minus 1. Okay, you have to be very careful on the calculator. I would not do this in one swoop. You can, if you really want to use a lot of parentheses, that's totally okay. Yeah. Okay, notice I did the subtraction already because if you do divided by 1.2 minus 1, this is incorrect. This is not the right answer. It's going to divide this by 1.2 and then minus 1 from the whole thing. If you want to do in one swoop like this, you would have to do divided by 1.2 minus 1. I'm too lazy to type all that, so I just did 1.2 minus 1 was 0.2. This is the correct answer. So be very careful, use parentheses. And to be honest with you, I a lot of times ask students to just write that because it's much easier to remember for the calculator. Anyway, 35,456. If it's not obnoxious, I'll write the whole thing out. Okay, so option one. Option one is payments over time. We already worked on this a bit. Sum equals. Okay, looking back at number 82C, what was the first term in Mr. Hank's series? Look at your 82C. 82C, what was the first term? 82C. 1,500,000. So I'm following the formula we just worked on. What was the multiplier? 1.05. And how many terms were there? Ah, huh?
Mr. Hank.
Yeah,
Oh, no, no.
yeah.
So like on a test, we're gonna have a few days to do it, right?
Next to quizzes, yeah. So Connor, here's the thing. Once you discover a formula, you don't ever need to discover it again. Oh. This,
No,
thanks.
I was joking. Your window's tweaking this tablet. I don't know what was going on with it. I mean, it was the bird. No. I mean, it was like hard, you know?
Keep your mouth shut, Leanne. Keep your mouth shut. Say anything, don't get fired. Just... Okay, now, if he gets the jackpot right away, the problem said that he gets 51% of 5 million. It was 5 million, right? The payout was 5. Was it 50 million or 5 million? It was 50?
Yeah.
Crap.
More than 5.
No, yeah, 50. I'm missing a 0. Okay. Does anybody remember how to find the percent of a number? Or
Oh, you got it. Okay. You did really good.
okay, so as much as it pains Mr. Hanks, should he get the lump sum right away? Or should he get the payments over time? Payments over time. And to be honest with you, if you win the lottery, first thing you do is get a lawyer and don't tell anyone. And secondly, take the payments.
Wait, why do you get a lawyer?
Yes.
What? No, why do you get a lawyer?
Just Google it.
No, help you with the finance. You also, how would you get someone to get the finance?
It's basically because like everyone in your life is gonna start trying to get money from you.